Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this is lecture on direct indirect proportion. So in this lecture, we are going to start with direct proportion in the very first section, in which we will first see the definition of direct proportion, and in the next section we will see example of direct proportion. And in the second section, we are going to study indirect proportion, in which we will first see the definition and then we will see example. And at last, in the third section, we are going to solve some problems on direct indirect proportion. So, the definition first. So, direct proportion is a concept where two quantities are related in such a way that when one quantity increases, the other quantity increases at the constant rate and vice versa. By vice versa, I means if the quantity, one of them is decreasing, then other should also decrease. So mathematically, if two variables x and y direct proportion, are in direct proportion, it can be expressed as y equal to kx, where k is the constant of proportionality. If x doubles, then y also doubles. If x is halved, then y is also halved, and so on. So let us see an example. So for example, cost is directly proportional to the number of articles. So more articles, more cost. Work done is directly proportional to the number of men working on it. That means more men, more work, less men, less work. Now, indirect proportion. So let us have a look over the definition first. Indirect proportion, also known as inverse proportion, is a relationship between two quantities in which one quantity increases as the other decreases at the constant rate and vice versa. That means if one of them increases, then other is going to decrease. If one of them decreases, then other is going to increase. So there is an inverse relation between the two. So if two variable x and y are in inverse proportion, it can be mathematically written as xy equal to k or y equal to kx, where k is the constant of proportionality. So in this relationship, as x increases, y decreases, and such that the product of two variables remains constant. And similarly, as x decreases, y increases, maintaining the same constant product. For example, the time taken by a car in covering a certain distance is inversely proportional to the speed of the car. For example, like you are in a car and you are moving. If your speed is more, then more speed, less time taken. Correct? If your speed is more, then time taken to cover certain amount of distance will be less. And if the time is you are taking more time, then definitely you are moving at a low speed. And in the second example, time taken to finish a work is inversely proportional to the number of persons working at it. So more person, less is the time taken. So earlier in the previous example, we saw more person, more work. That was a direct relation. But this is a relation between people and time. That is inverse. More people, less time required. Less people, more time required. Now, that was all about theory that we had to discuss in direct and indirect proportion. And now we are ready to discuss some questions on these topics. So if 10 toys cost 250 rupees, then what do 25 toys cost? So let the required cost be x. So we don't know what is the cost, so we assumed it to be x. Then more toys, more cost, that is direct proportion. Therefore, 10 is to 25 as 250 is to x. So 10x is equal to 25 into 250, that is equal to x is 625. So the correct option here is option B. Question number 2. If 16 men can do a piece of work in 15 hours, in how many hours will 10 men do it? So let the required wages be x. So less men, more hours, that is indirect proportion. Therefore, 10 is to 16 as 15 is to x. So 10x is equal to 16 times of 15, that is equal to x is 16 into 15 upon 10, that is 24 hours. So the option correct here is option C. Question number 3. If 405 is to y as y is to 125 and y is greater than 0, then find the value of y. So when this is given to us, that means they are trying to say this. So y times of y is equal to 405 times of 125. So y times of y, we can break down these numbers as 5 times of 81 times of 5 times of 5 times of 5. So this is equal to this, and 5 threes, 3 fives is equal to 125. And further breaking it down, we will have 5 into 5 into 5 into 5, and 81 also broke down to 9 into 9. And now you can see we have one pair here, one pair here, and one pair of 9 here. Now you must be thinking why we are doing that. You could have just multiplied these two numbers and calculated the root of that. But you think that it is going to be a little bit tedious. So we are going to use prime factorization method to find the root, square root. So when we break down like this and now identify the pairs, so y will be equal to 5 into 5 into 9, choosing one number from each of them. So it is going to be 2 to 5 hours. So the option correct here is option A. Now, question number 4. 3 pumps working 8 hours a day can empty a tank in 2 days. How many hours a day must 4 pumps work to empty the tank in 1 day? So let the required number of working hours per day be x. So the more pumps, less working hours per day. That is an example of indirect proportion. So less days, more working hours per day. So the pumps are in ratio 4 is to 3. So the days will be in the ratio 1 is to t as 2 as 8 is to x. So it is going to be 4 times of 1 into x equal to 3 times of 2 times of 8. And when you simplify this to obtain the value of x, you will get x equal to 12. So the correct option here is option D. Question number 5. If cost of x meters of wire is d rupees, then what is the cost of y meters of wire at the same rate? So the cost of x meters is d rupees, that is given to us in the question. So what is the cost of 1 meter of wire? So that is d upon x rupees. So now what will be the cost of y meters of wire? That will be d upon x into y. So the correct answer here is yd upon x. So option correct here is option D. Question number 6. Running at the same constant rate, 6 identical machines can produce a total of 270 bottles per minute. At this rate, how many bottles could 10 such machines produce in 4 minutes? So let the required number of bottles be X. So more machines, more bottles, that is a direct proportion, and more minutes, more bottles, that is also a direct proportion. So the machines are in ratio 6 is to 10 and time is in the ratio 1:4 as 270 is to x. So that means we can write it as 6 times of 1 into x equal to 10 times of 4 into 270. And when you simplify this, you will get x equal to 1800. So the correct option here will be option B. Question number 7. A fort had provision of food for 150 men for 45 days. After 10 days, 25 men left the fort. Find the number of days for which the remaining food will last. So after 10 days, 150 men had food for 35 days. Now suppose 120 men had food for X days because 25 men left. Now only 125 men are remaining in the fort. So how much time that food is going to last now? Now less men means more days. Less men means more food will be there. So more days it will last. So there is a relation that 125 is to 150 as 35 is to x. So 125 into x will be equal to 150 into 35 and x is going to be 42. So the option correct here is option C. Question number 8. 39 persons can repair a road in 12 days, working 5 hours a day. In how many days will 30 persons working 6 hours a day complete the work? Solution. Let the required number of days be x. So less person, more days. Correct. If the people are less, so to do the work, more days will be required, which is an example of a indirect proportion. And more working hours per day will require less days. So which is again a indirect proportion. So the people are in ratio 30 is to 39 and working hours slash day is in ratio 6 is to 5. So days is 12 is to x. So we have 30 into 6 into x equal to 39 into 5 into 12. So x is equal to 13. So the option correct here will be option B. Question number 9. A man completes 5 upon 8 of a job in 10 days. At this rate, how many more days will be required to finish the job? Solution. So work done is equal to 5 upon 8. So if the total work is 1 and he have completed 5 upon 8 out of it, how much work is remaining? So the balance work will be given by 1 minus 5 upon 8, that is 3 upon 8. So let the required number of days be x. Then 5 upon 8 is to 3 upon 8 as 10 is to x. So 5 upon 8 into x is equal to 3 upon 8 into 10, that is equal to x is 6. So the option correct here is option B. Question number 10. If a quarter kg of potato cost 60 paise, how many paise will 200 gram cost? So let the required weight be x kg. So less weight, less cost, which is an example of direct proportion. So here we have 250 is to 200 as 60 is to x. So 250 into x is equal to 200 into 60. So x will be equal to 200 into 60, that is 250 upon 250, that is x equal to 48. So it will be 48 rupees. So the option correct here is option A. Now, question number 11. In a dairy farm, 40 cows eat 40 bags of husk in 40 days. In how many days one cow will eat one bag of husk? So let the required number of days be x. Less cows, more days. That is an example of indirect proportion. And less bags, less days. That is an example of direct proportion. So cows are in ratio 1 is to 40, bags in 40 is to 1 as 40 is to x. So here we have 1 times of 40 times of x equal to 40 times of 40 times of 1. So the x will be 40. So the correct option here is option C. Question number 12. A wheel that has 6 cogs is meshed with larger wheels of 14 cogs. When the smaller wheel has made 21 revolutions, then find the number of revolutions made by larger wheel. So let the required number of revolutions made by larger wheel be x. Then more cogs, less revolutions, that is a indirect proportion. So here we have 14 is to x as 21 is to x. 14 is to 6 as 21 is to x. So it will be 14 times of x equal to 6 times of 21, and it is x equal to 21 times of 6 into 4 upon 14. So x will be 9. So the option correct here is option B. Question number 13. If 7 spider make 7 webs in 7 days, then one spider will make one web in how many days? So let the required number of days be x. So less spider, more days, that is the indirect proportion, and less webs, less days, that is a direct proportion. So if there are less number of spiders, more days will be required to make the web, and if there are less number of webs that are to be made, so it will require less days. So spiders are in ratio 1 is to 7 and webs are in ratio 7 is to 1 as 7 is to x. So it will be 1 into 7 into x equal to 7 into 1 into 7. So x will be equal to 7. So one spider will make one web in 7 days. So the option correct here is option C. Question number 14. A camp of soldiers has food for 200 days. After 20 days, 100 more soldiers join the camp and the food now can last for 80 days. What was the initial number of soldiers in the camp? So the solution, let the number of soldiers be x and total available food is equal to x into 200. So the food consumed by x soldiers in 20 days will be x into 20, and now 100 soldiers joined the camp. That means new number of soldiers is going to be x plus 100. So now the rest of the food is finished in 80 days by x plus 100 soldiers. Therefore, the food consumed in 80 days is equal to x plus 100 into 80. So according to the question, 200x is equal to 20x plus 80 times of x plus 100. That is 200x equal to 100x plus 8000. That is 100x equal to 8000, which means x is equal to 80. Therefore, the initial number of soldiers are 80. The option correct here is option D. Now, question number 15. A work could be completed in 100 days by some workers. Due to the absence of 16 workers, the work was completed in 100 days. Find the original number of workers. So in this question, there is certain work that have to be done, and there are some n number of workers which were supposed to complete it in 100 days. But due to some reason, 16 workers were absent, and now the task took 8 more days to get completed. So what was the original number of workers? So the solution, the total work done is equal to the product of number of workers, time taken and efficiency. So the total work is equal to number of workers, time and efficiency. So let the number of workers be x. So the work could be completed in 100 days by x workers. So due to absence of 16 workers, the work was completed in 100 days. So this information is already given to us in the question. So according to the given information, 100x is equal to x minus 16 times of 108, and simplifying this above equation, we get 100x equal to 108x minus 1728, which is equal to 216. So the value of x is 216. Therefore, the original number of workers was 216. So the option correct here is option D. Now, question number 16. A camp of soldiers has food for 400 days. After 40 days, 150 soldiers leave the camp. As a result, the food can last for 480 days from then onwards. What was the initial number of soldiers? So there is a camp in which we have food capacity or food stored in the storage house for 400 days. And after 40 days, 150 soldiers left the camp. So as a result, the food can last for 80 more days, that is 480 days. So what was the initial number of soldiers in the camp? So the food is sufficient for 400 days. That is given to us in the question. And let us suppose the initial number of soldiers be X. That is unknown to us. So after 40 days, the remaining soldiers are X minus 150. Correct? And now the food is sufficient for 480 days for the remaining number of soldiers, that is x minus 150. So as the total amount of food is the same, so we can equate them. So x into 400 is equal to x minus 150 into 400 plus 40x. So 10x equal to x minus 150 into 12 plus x. So x is going to be 600. So the initial number of soldiers that were there in the camp is 600. So the option correct here is option B. Question number 17. A camp of 250 soldiers has food for 600 days. After 60 days, 50 soldiers leave the camp. For how many days will the remaining food last from the time that these 50 soldiers left? So in this question, there are 250 soldiers in a camp and the camp has food for 600 days, which is enough for 250 soldiers. So after 60 days, 50 soldiers left. That means 200 soldiers are remaining in the camp. So for how many days will the remaining food going to last from the time that these 50 soldiers left? So let us have a look over the solution. A camp of 250 soldiers has food for 600 days. After 60 days, 50 soldiers leave the camp. So here we are going to use a formula that is M1D1 equal to M2D2. So let's assume the remaining food lasts from the time that these 50 soldiers left is X days. So 250 into 600 is equal to 250 into 600 plus 250 minus 50 into X. So here we have 250 into 600, that is equal to 250 into 600 plus 200 into x. When you simplify this, you will be left with 250 into 3 equal to 225 into 3 plus x. So we just got rid of this 200. We divided the whole equation with 200 and now we are left with just multiply this, it will be 750 and this will be 75. Just send this to the left hand side, you will be left with x equal to 750 minus 75. So x will be 675. Therefore, the remaining food will last for 675 days from the time that these 50 soldiers left. So the correct option here will be option C. So thank you all, and that would be all for this lecture. And I will recommend you to try all these problems by your own. And I'll see you in the next class with some more problems on direct indirect proportions. Thank you.